Hello guys, welcome to the channel. Welcome to my new channel, Medicinal Pharma Education. In the previous class, we have discussed about the uh, spectrofluorometry topics. We have discussed about the principle involved in and the mechanism of fluorescence and fluorimetry, and we have also discussed the factors affecting the fluorescence. If you have any doubts regarding that, you can just comment me. I will just comment back with an answer or an explanation. Okay guys, and today's topic is quenching and the instrumentation and the application involved in the spectrofluorometry. By this video we will complete the spectrofluorometry, and three chapters will be completed by this video: the UV visible spectroscopy and the IR spectroscopy and spectrofluorometry. Okay guys, let's continue with our video. Quenching is the reduction of fluorescence intensity by the presence of substance in the sample other than the fluorescent analyte. Here quenching is just defined as the substance which is present in the sample which decreases the fluorescence of an fluorescent analyte. Okay, next there are four types. We already studied the quenching in the factors affecting. Means quenching is nothing but which reduces the fluorescence or fluorescent, which reacts with the fluorescent analyte and decreases the fluorescence. This is the main concept of quenching. Quenching is mainly divided into four types: self quenching or concentrated quenching. Next is chemical quenching, collisional quenching, and static quenching. By these are the four types where by this process the fluorescence of the substance is decreased. Okay, firstly self or concentrated quenching. Okay, see, it depends on the concentration microgram per ml of the substance. At low concentration, linearity is observed. Okay, at low concentration, linearity observed, and at high concentration of the substance, proportionate increase in the fluorescence intensity does not occur. See, it is telling that at the low concentration, the linearity is observed. Okay, the if the amount is like 100 microgram per ml, 100 microgram per ml, if the amount of sample is produced and particular fluorescence amount or intensity is produced. Okay, if if we take more than, in this case, higher concentration, what is happening, right? Here we are taking like 500 microgram per ml, 500 microgram per ml. Here we should get like 500%, right? Here if we get 100% of intensity, we should get 500% of intensity. Okay, but in this case, self quenching, what is happening in this concentrated quenching, we are not getting the 500% quenching. That's the it is telling. See, at higher concentration, as we increase the concentration, at higher concentration, it is telling that higher concentration of the same substance, proportionate increase in the fluorescent intensity does not occur. That's what the meaning of self quenching. I think so I have understood. If 100 microgram per ml produces 100% intensity, then 500 microgram per ml should produce 500% of the intensity, but we are not getting 500% of the intensity. We are getting like lower, like 250%, 250%, or 300%. That is called as self quenching. We are not getting the value which we got in the low concentration. That's what is self quenching. In high concentration, the concentration has increased but the intensity has not increased. That is self quenching. I think so I have understood. I have explained it in an easy understandable language. If you have not understood, just comment me. I will just explain in a better way. Next, chemical quenching. Chemical quenching is nothing but chemical interaction of the fluorescent substance. Here chemically the fluorescence is decreasing. There are many factors that affects the fluorescence. We have already discussed. The pH affects the fluorescence, presence of oxygen decreases the fluorescence, halides and heavy metals, these also presence decreases the fluorescence. Okay, next, static. As this static quenching is that this occurs when a complex is formation. See, when complex is formed, the fluorescent substance is converted into non-fluorescent substance. Here, example, caffeine reduces the fluorescent intensity of riboflavin. I think so. I've got it. By complex formation of caffeine and the riboflavin, the fluorescent intensity is decreased. Okay. Next, collisional quenching. Here, collisions between the fluorescent substance and halide ions leads to decrease in the fluorescent intensity. See, usually the collision between the just fluorescent substance increases the fluorescence. Okay, but interactions or collisions between fluorescent substance and halide ions decreases the or reduce reduction in the fluorescence intensity. That's the difference. Okay, next we are going to start with the instrumentation is not that much important, but for completing your 100% syllabus you have to read this topic. It's very easy topic, because the light source we have already studied, the monochromators we have already studied, sample handling or the cuvette we have already studied, detectors we have already studied, amplifiers we have already studied, readout devices we have already studied. You have to just recall the previous classes and just memorize this topic and implement the previous topics in this topic. That's it. Okay, let's start. See, I'll just explain you the instrumentation. Right. I think so. We are seeing the instrumentation. First, xenon lamp. We have already discussed xenon lamp. Then it is a light source where it passes through the grafting, where the polychromatic light is converted into monochromatic light, and the slit, it is passed through a slit, and it here the sample, here it is here only the emission is absorbed, right? Emission or in this the principle is based upon emission, so emission takes place at only 90 degrees, so that we use 90 degrees, the sample is placed at 90 degrees. Okay, next here half light will be the light is breaked into two. It goes through the receiver detector and this reference sample and the standard sample, and we have two detectors in it. Photomultiplier is a common detector which we have already discussed in the UV instrumentation, and we use the UV instrumentation, then the computer or readout devices. See, the cuvette is placed at 90 degrees, where we detect only the emission of the radiation. Okay, let's discuss one by one. Okay, first, the source of light. The source of light emit the source of light emit is radiation over a continuous region and be adequate intensity and stability. We have already discussed the ideal properties of the light source. The same points you can write in this, and there are divided into three types: mercury vapor lamp, xenon arc lamp, and tungsten lamp. We have already discussed these two. You can just list out the types and explain any one of them, okay, if they ask. And here the monochromators or the filters are very important, as we have already discussed. With the help of filters, the selection of the wavelength is done. They use primary monochromators and secondary monochromators, as we can see in the detectors itself. Here primary monochromator and secondary monochromators. Next, what is meant by primary monochromator? It includes the slit and dispersive device to isolate the wavelength of excitation of sample. See, here the primary monochromator will select the wavelength. Isolate means select the wavelength for excitation of the sample. Okay. Next, secondary monochromator, it includes a slit and dispersion device to isolate the wavelength of emitted fluorescence of the sample. Okay, I think so you have understood. For emitted fluorescence, for secondary monometer, and primary excitation of sample, the wavelength for excitation of sample. This is the difference between primary and secondary. Okay, next, sample cell, it's the same. We use the cuvette or it can be cylindrical or hexagonal. The samples are cylindrical or polyhedral. It should not be made up of quartz. See here, the material should not be made up of quartz, because only we are measuring only, since we are measuring only the emitted radiation but not the absorption radiation. Quartz is used when we are finding the absorption of radiation. Okay, next. Sorry, I did not on the camera. Next, here even there is an absorption of radiation by the glass, it should not affect the result. If the absorption is also occurring, if the absorption cannot be prevented, then the result, it should not affect the result. Okay, it should not affect the result. And all the surfaces are polished in the fluorimetry, because emission measurements are made at 90 degrees angle. I have already said you, right, the emission measurements are made at only 90 degrees angle, so that there the surfaces are polished. Okay, the detectors types we have already discussed in the UV instrumentation, so you can just refer the UV instrumentation, where I have made a separate video on the detectors. You can just go and see phototube, photomultiplier, and a photovoltaic cell. You can just read this photomultiplier. This is very important. They will directly ask the photomultiplier mechanism and the diagram. Okay, next, the readout devices. The readout devices are recorders. A galvanometer or the potentiometer is used as the readout devices. By this we complete the spectrofluorometry, and next we are going to start the flame and atomic absorption spectroscopy. By that we will complete the spectroscopy concept, and next we will go for NMR concept. Okay, thank you guys for watching, and please subscribe and comment if you like the video. If you did not like the video, just comment what's the problem you are facing. I'll just try my level best to explain in a better way where you can understand it easily. Thank you guys. Bye. See you. Take care. Study well. Radhe Radhe.